In this lesson, we're going to be taking a look at logarithms. Now, logarithms are an idea that's going to come up quite a bit later in our course, but for now, I just am going to introduce the very basic idea of it, and I'm going to leave some of the explanation for later. Because one of the things that happens otherwise is that people get so caught up in just trying to figure out what does this logarithm thing mean, like just what is the very basic nature of it, that it makes it harder to learn some of the deeper, heavier stuff about them later on. So we're going to build up a foundation here early in the year before we go and start digging deep into it. Now, to start with, basically the main thing you need to know about logarithms is that they're just a different way of writing an exponential equation. Let's actually take some notes here and see exactly what I mean. And yes, I did say notes here. You'll want to write this down so you can look back at it later. I highly, highly, highly recommend that you have a single place where you keep all of your math notes, so anytime you forget something, you know where to look for it. So, what we see here, you'll notice first, I have an equation here, b to the power of x equals y. This is an exponential. What makes it an exponential equation is the fact that the variable is in the exponent. If we have x in the exponent, we call that an exponential equation. Now on the other side, we have something that's going to look completely new to you. We read this as log base b of y equals x. We call that a logarithmic equation because it has a log written in it. Now when we write a logarithm like that, notice how I read it as log base b of y equals x. The base is what's called a subscript. A subscript gets written smaller and lower. And so this b is actually a smaller sized b than it would be if it were, for instance, right here or right here. We write it smaller and we write it lower. Kind of like when you write an exponent, you write it higher and smaller. With a subscript, you write it lower and smaller. The other thing I'll note about how it's written is that sometimes when we write our logarithms, we'll put parentheses around where the y is, which we would call the argument of the logarithm. And so after we've seen all of this and seen, okay, that's how we write it, we write the base lower, stuff like that. What does this whole thing up here actually mean? This little double-ended arrow here basically means that these two are equivalent. Now, I'm not using equal sign because notice we have equal signs in here. It's a way to say that these two equations both are saying the exact same thing. So these two are considered equivalent statements. That is, if I evaluate one for x, I know what the other one equals for x, and so on. They are identical statements, just written different ways. And that's the key thing to understanding logarithms at this point, is just that these really do mean the exact same thing. Make sure you do have this written down now, because the next thing we're going to do is we're going to go and practice switching between these two different forms. So in this case, we are going to be writing each of these exponentials as logarithms. So we have two separate problems here. Our first one here is 5 to the power of x equals 10. Now remember, it's an exponential, and therefore I can rewrite it as a logarithm and have it still mean the same thing, and that's our goal here. Whenever you're going to be writing a logarithm, I'd suggest that the very first thing you write be log. And that comes from this form up here. Basically what I'm doing is I'm entering in what the equivalent form is going to be. So I write the log. The next thing I need to write for that is what base b is. Now you'll notice in our other side of this that b is whatever was raised to the exponent. So the 5 here is playing the role of b. And so 5 is my base. So we're going to do log base 5 like that. Again, remember that the base gets written smaller and lower. Okay, next up, I'd have to put in whatever y is. So then I look on the other side of this thing and look to see what the y is. Notice that the y is whatever was left on its own. It's what the exponential equaled. In this case, that would be the 10. And so then, we're going to have to put the 10 next. Now remember, I can write it like that, of just log base 5 of 10, or I can do log base 5 of 10 with parentheses around the 10. Either one works. They are equivalent. Later, when we get really complicated, we'll have to put the parentheses in some of them. But if it's only the one argument inside, we can omit the parentheses. All right, the next thing that we put in there in our logarithm equation is the equal sign. And then the last thing is x. Notice where the x came from over in the other side. The x was the exponent. So in this case, the x, well, is x. And so we have log base 5 of 10 equals x. Yes, these are equivalent here. So these two statements, this first exponential and this logarithm, they mean the exact same thing. They're just different ways of writing it. Why would we want to write it the other way? That's where we're going to go later once we've gotten used to switching the signs, but we're going to find that we can actually calculate things using these logarithms that we could not calculate otherwise. All right, let's go ahead and head into the next one now. So we're now going to figure out how we would rewrite this as a logarithm. Before I walk you through it, take a moment on your own here. Go ahead and try writing it on your own as a logarithm first, so you can check yourself against what we do together. So first up, you'd want to write the log, then the base. Well, the base, remember, is whatever is raised to the power of x. In an exponential, that is what the base is called. It is whatever is raised to the power of x. We call that the base. So the base of my exponential here is the h. So we're going to do log base h of, so notice the y there, that came from whatever my exponential equaled. And therefore, that's going to be the w. And then that equals the x. Okay, notice where the x is. The x is the exponent. One of the ways that I remember this is in my head, I always remember that log equals the exponent. And so whatever the exponent is from the original, that's what log has to equal, because log always equals the exponent. And with that, these two are done. We have successfully now written each of the exponentials as a logarithm. The last thing I want to note about these two answers, though, is that we started by writing log in both cases. So in both of these cases, log ended up on the left side. But these are equations. There's nothing magical about what is on the left side and what is on the right side. And so if instead you had chosen, for instance, for that first one to write x equals log base 5 of 10, that would have been fine. On the second one, if you had written it as m equals log base h of w, that would also be perfectly fine. So there's nothing magical about the left versus the right. All of that is interchangeable because they're equations. All right, now having done these, you see that we changed the form from exponential into logarithm. Because they're equivalent forms, we can go the opposite direction too. So let's now go and practice going the opposite direction in this transformation. So let's practice that. Here are two logarithms, and we want to write each one as an exponential now. So first up, we have log base 2 of x equals 4. So the first thing I want to write in my exponential is the b. And so the b here comes from the base of my logarithm, which in this case you'll notice is 2. So we're going to start by saying 2, and then the next thing in our exponential is the exponent. That's x. Notice where that is, because remember, log always equals the exponent. And so if log equals the exponent, then my exponent must be 4 in this case. So we're going to do 2 to the power of 4. The next thing is the equal sign, and so put in the equal sign, and then the y, which by process of elimination, you can kind of figure out where that needs to be, right? It tells us that that's going to be what x is. And so we're going to do 2 to the power of 4 equals x. And that one is now done. The cool thing about this problem is it also shows you how we can actually figure out what logarithms can equal. Because we just figured out what x was in this logarithm, because we just figured out that x equals 2 to the power of 4th, which we could then calculate. It equals 16 as it so happens. So you could actually figure out what x equals by rearranging these. And of course, we're going to use that to our advantage down the line to figure out what x equals when it's in the exponent of an exponential and things like that too. All right, the last one here. Again, I'd like you to go ahead and try doing this one on your own before we do it together. So go ahead and rewrite this one as an exponential. The first thing we're going to be putting down on our paper is the base here. So our base in this case is n. So we're going to do n, and then it's got to be to the power of, and remember log always equals the exponent. So my exponent here must be c. So we're going to do n to the power of c equals, well, notice the only letter we haven't used yet is the a. So obviously it must equal a then. And so n to the power of c equals a is the exact same thing in exponential form. And just like in the last problem, there's nothing magical about what was on the left side and what was on the right side of our equations here. So on this first one that we did, if you had written it instead as x equals to the power of fourth, that would have been perfectly fine. Or on the second one, if you had written it as a equals n to the power of c, yes, that would also have been perfectly fine. So it is flexible to go either way. We just tend to write it in this particular order because that's the way we see it in our notes, and so it's the way we get used to doing it. And that's the only reason why we tend to go to that particular order.